Okay, so today's lesson is going to talk about some special functions, some equations and relations that behave in very interesting ways. So we're going to talk about step functions, constant functions, and the identity function. And there's two kinds of step functions, and they're named this way because they look like steps. And they really are going to reflect intervals of constant behavior. So if you think about your cell phone plans, you pay for every part of a minute you use. So if you talk for 1 minute 20 seconds, you actually get charged for 2 minutes. It rounds up, and this is called a ceiling function. If you, as in our example, make a counseling session appointment and you are only there for 1 hour 35 minutes, you're actually going to potentially be charged for 2 full hours because they round up for any fraction thereof, any fraction of an hour, fraction of a minute. Postal rates are this way. You pay for 1 ounce of mail is 44 cents. 1.1 ounces, you have to add 20 cents. 64 cents. 1.9 ounces, still 64 cents. As soon as you get to 2 ounces, it becomes the next charge, which would be 84 cents. So here we're going to talk about the psychologist who charges for counseling sessions at the rate of $85 per hour or any fraction thereof. So if you think about X, which is our hours, and our function, which is the money. And so if you are there from 0 hour, because you can't pay, up to and including 1 hour, you get charged $85 for any portion of that time. From 1 hour 5 minutes up to but not including 1, up to and including 2 hours, you actually get charged for 2 times 85. Which is $170. If you are there 2 hours and 10 minutes, up to including 3 hours, you're actually going to pay 3 times the hourly rate, which is $225. And it would continue on that way. Now when we go to graph this, we're talking about at 0 hours open, we don't pay anything. But then it's a constant rate no matter how much of that first hour we use, up to and including 1 hour, $85. Then we're going to jump up to the next one, which is at 170. At 1 hour, we're still paying $85, but at 1 hour, 1 minute, we start paying $170, and we play that all the way up until we get to 2 hours. At 2 hours, 1 minute, we jump up to $225, and we stay constant all the way to 3 hours. This is actually called a ceiling function because everything gets pushed up. You round up to the closest, every fraction plus, so you go to the next higher. The opposite of this is the greatest integer function, which is where you round down, and that's called a floor function, and you're rounding down. So we're still going to be looking at how does this behave, how does this function behave over this interval, and this is the symbol that tells you the greatest integer function that you're supposed to round down. So let's look at some inputs and the outputs. And our inputs are going to be ranges of values. So if I look at ranges of values between -4 and -3, how is this thing going to behave? So I'm going to go over here and I'm going to try. So what happens if I put -4 in? I'm going to get -0.5 times -4, which equals +2. Well, that's a whole number, so I don't round down. Oops. This is a positive. Negative. Sorry. Too many negatives. It's a -2. It doesn't round up or down because it is a whole number. What happens if I put -3.5 into this function. And I have this 0.5 times negative 3.5. Well, now I'm going to get negative 1.75. But I need to round down, and if you think about on a number line, here's negative 1.75, rounding down means negative 2. And that behavior would continue all the way up to negative 3, not including it, because then at negative 3, my answer will change. So let's look at what happens at negative 3. So at my integer function, I have 0.5 times negative 3 is negative 1.5, which is still negative 2. But I had to round down, so it's up to but not including negative 3. When I get to the next, because if you look at negative 4, it became exactly negative 2. This is my first interval, and that's why I have a less than or equal to and a less than. So then my next interval starts at up to including negative 3 and through negative 2. So I know at negative 3, my value is going to round down. It's not going to be exact. What is my next choice? So let's take negative 2.5 and put it in there. And at that point, we have 0.5 times negative 2.5, which is going to equal negative 1.25. And now when I round down, if you think about where this is, I'm at negative 2. So my interval is actually, looks like it's probably going to stay the same. So let's test another one in that interval. So let's test negative 2 itself and what happens. And when I test negative 2 itself, I get 0.5 times negative 2. And now I'm going to get negative 1, which is negative 1. And this is where my interval suddenly changes, is right here. And now negative 2 is going to produce a different value. But I'm still going to keep my intervals so I can check what is going on here. So when I put negative 3 and negative 2, it's still rounded down to negative 2. As soon as I bounced up to negative 2, I got out negative 1. And I'm going to check again. What happens if I put negative 1.5 in here? And I take 0.5 times negative 1.5. And I'm going to get negative 0.75. That rounds down to negative 1. What happens when I put negative 1 into my function? And I have 0.5 times negative 1. And that's going to give me negative 0.5, which still rounds down to negative 1. So that interval produces negative 1. What happens over the next interval? So I start inserting values again. And so this time I'm going to use negative 0.5. And you need to do enough of these until you see how your function is behaving. What is the pattern of its behavior? Because once you know its pattern, you can graph it. Now negative 0.25, if you think of a number line again, negative 1 and 0, negative 0.25 is right there. It's still going to round down to negative 1. And so the pattern here, up to 0, is that it's repeating every 2 units. So when I go to do my graph, from negative, because these are the same, from negative 1, 2, 3, negative 4, negative 2, it was exact there, up to but not including negative 2. That covers those two. And then the next interval is from negative 2, but my output was negative 1, up to but not including 0. So my next interval should start here and continue. And my next interval will start here, 2 units, and be open. And you can test values as you go along. Now let's look at this one over here. Here we're going to round down and then subtract 2. So when you check your intervals here, they're going to change more frequently. So let's look at x and f of x for this graph. If I put negative, let's check my first interval from negative 3 less than or equal to x less than negative 2. If I put 1.5 in, or negative 2.5, negative 2.5 minus 2, and I round down, so this is going to become 3 minus 2, so that area becomes, whoops, negative 3 minus 2, start that over. Negative 2.5 minus 2 becomes negative 3 minus 2, which becomes minus 5, not absolute value, integer. Sorry about that. If I look at my next interval of negative 2 is less than x is less than 1, and I pick 1.5 to see how it behaves, so that's the value of negative 1.5 minus 2 is going to be negative 2 minus 2, which is negative 4. And my next interval, if I pick 0.5, and you could pick 0.3, I'm using 0.5 because the math is easy, but let's say even if you picked negative 0.3, or negative 1/3, minus 2, that's going to round down to negative 1 minus 2, which is negative 3. Now, you might be wondering how I knew what the endpoints were. I should check my endpoints to make sure if this is a ceiling function or a floor function, even though the greatest integer function is always a floor function. But if I check my endpoint and I put, say, negative 3 in here from my first interval, you'll see I get negative 3 minus 2, which is minus 5, my exact value. When I put negative 2 in, I get negative 2 minus 2, which is negative 4, which is the next value. So if I go up to but not including negative 2, it's going to round down. As soon as I switch to negative 2, it's going to bounce back up. So you can start to see my pattern is emerging, and that's going to be negative 2 from 1 is less than or equal to x is less than 2 is going to be negative 1, and it will continue. So what does my function look like? So at 1, 2, 3, negative 3, it's going to come out 1, 2, 3, 4, 5, up to this. And then that pattern from negative 2 to negative 1, any value that comes out of it is going to be negative 4. And so my function is going to continue on this pattern all the way up. I will continue the rest of the lesson in the next video.